Good morning, grade nines. So I'm just doing a video lesson here to go along with the PowerPoint. So we're now on lesson 3 of unit 1. So we're still talking about, we're still in our unit about rational numbers, but now we're getting more into specifically what rational numbers are. And then we're going to talk very briefly about the cross cancellation method. So that's what we're covering in today's lesson. So just a reminder, you should always go through the actual lessons that I post on there. But I will sometimes every now and then have a video lesson to go along with it. So I would still recommend going through the PowerPoint first and then going through the video lesson. Just if it helps to just have more of an audio to kind of go along with the lesson itself, and then you can kind of see me work through the problems directly. So first thing I'm going to do is just kind of quickly recap what rational numbers are, and then talk about our number system that we use and how we subdivide numbers. So first thing is natural numbers. So natural numbers are the counting numbers. So these are the numbers that we're most familiar with, right? Ever since kindergarten or ever since you were really young, these are the numbers you learn, right? So 1, 2, 3, 4, all the way up to who knows what, right? So those are our counting numbers. Those are the full like positive numbers that we work with. Then we have whole numbers. Whole numbers, essentially what we're doing is we're including all natural numbers, but really important emphasis here, we include 0 as well. So this Venn diagram right here that you can see in this picture kind of illustrates this idea that all the natural numbers are inside of the whole numbers, right? So whole numbers is the name of the whole entire big group of all the numbers, all the positive whole numbers plus 0. So 0 is the only a new element that's been added on into this group, okay? Then we have integers. Integers are basically positive and negative whole numbers. And essentially, those are we're essentially just extending out our number line. So if you almost picture a number line here, and actually it's a very bad number line, I apologize. It should be a little more straight. So 0, 1, 2, 3, 4. Let's see, I just have a couple numbers here. If when we are looking at integers, we're essentially just extending out our number line, and we're just including the negative whole numbers as well. Keep in mind, we're not including decimals yet, right? So we're not including fractions yet, and I'll talk a little bit about that. So we're not saying like, -3.5 or -4.5 or something like that, right? We're just including positive and negative whole numbers. And our last big group that we want to talk about is rational numbers. So rational numbers is basically kind of a bigger subset. So if you can kind of picture here, the Venn diagram kind of shows it, that natural numbers fit inside of all the whole numbers, right? All whole numbers are obviously are also integers as well, while natural numbers, whole numbers, and integers are all part of this bigger group of rational numbers. And rational numbers, by definition, are basically numbers that are of the form a over b. So we can essentially write it as a fraction. And a and b themselves are integers. Now there's one really special condition, and you definitely want to make sure that you're careful with this. B cannot equal 0. Okay, the denominator cannot equal 0, and the reason for that, don't want to go into too much detail, but it's because we cannot divide by 0. If you're interested, just out of curiosity, you can definitely look up the reason for that. If I had a little bit more time, I would definitely cover that. But for now, essentially just remember that rational numbers can be written as a fraction a over b, where b cannot equal 0, right? And again, a and b here are integers. A lot of times in math, we'll tend to use letters to represent numbers that we don't actually know yet. A and b are literally just two integers that we don't know at the moment, right? But essentially what we're saying is, as long as you have, if you can write the number as a fraction, where the numerator and denominator are integers, so positive and negative whole numbers, and including 0, as long as b is not equal to 0, then it's definitely a rational number. So another way to tell if a number is rational or not is to actually look at its decimal equivalent. So I hope you went through the quick overview of decimal numbers because it has a lot of the same information here. But it kind of briefly outlines how to switch from fractions to decimals. And when we talk about switching fractions to decimals, just so you know, we're essentially just finding a decimal equivalent. It's the same number, we're just writing in a different way. So if I were to switch this fraction here, 1 over 4 into a decimal, I'll just that, I can see that it ends up being 0.25. And I'm hoping everyone is kind of familiar with this. This is one of those fraction decimal equivalents that you should really remember because it comes up quite a bit. And obviously this is, we can see here that this is a terminating decimal, meaning that the decimal actually just ends, right? It doesn't continue on. But then we have other examples like 1/3. We can see here that this one actually does continue on. And if you actually put this in your calculator, 1 divided by 3, you end up getting 0.333333. It's going to go on forever, right? But the main thing to remember is that this may not be terminating, but it has a repeating decimal, which basically means that we notice a pattern. There's a set of digits that keep repeating over and over. And in this case, it's actually the 3 that keeps repeating. So we can actually write this in math using a symbol. We write a dash over top of the 3, which basically means that that 3 continues on forever. And finally, we can see 2/11. If I want to switch 2/11 or 2/11s into a fraction, into a decimal, I simply take 2 and then divide by 11. And if I take 2 divided by 11, I end up getting 0.181818. You can put this in your calculator, check yourself. And what I noticed is that instead of this number repeating, so instead of me writing out all the digits here, which is not possible, what you want to do is simply put a little dash over top of the 18, because we're essentially saying that that digit 18 repeats, that set of digits 18 repeats over and over again. And then finally, we have a bigger group of numbers that we're actually not going to talk about, but it's just good for you to kind of be aware of this. Irrational numbers. Irrational numbers are basically the opposite of rational numbers, right? It's real numbers, and there's a reason I say real numbers, that are not rational numbers, okay? So essentially what that means is that they cannot be expressed as a fraction. And so you're gonna, as we talked about with rational numbers, we see a bit of a pattern when we find the decimal equivalent. You don't see that same type of pattern when you look at irrational numbers, and we'll look at some examples. The other important thing I want to bring up, the fact that I really highlight real numbers. You're probably wondering, what are real numbers? What do I mean by that? Real numbers are essentially, the reason we specify that is because there's actually a different set of numbers that you have never heard of, and I'm not making this up. It is called imaginary numbers. You don't need to know what this is. This is a bit more complex, but basically imaginary numbers are numbers that don't actually exist, but mathematicians have created a set of numbers to work around the fact that we can't take the square root of negative numbers. So because of that, they created imaginary numbers. So when we talk about real numbers, we're basically just talking about all the numbers that we're familiar with, right? So I'm talking, decimal numbers, like, as an example, I could have like, a decimal number that's like 1, 2, 3, 4, 1, 2, 4, 5, 7, blah, blah, blah. And it might continue on forever. This digit might go on for a long time. That would be an example of a real number. And specifically, it would be an irrational number if there doesn't seem to be a pattern with it, right? And if I can't write it as a fraction, that's the main rule here. If I can't write it as a fraction, then it's definitely not a rational number, and it's an irrational number. But this is still a real number because it still is a number that exists that we work with. And again, imaginary numbers, don't need to worry about what that is. But for now, whenever we talk about real numbers, we're talking about all the numbers we're familiar with, right? So again, don't stress too much about irrational numbers. The main thing you need to know is what rational numbers are, right? That's what we're going to work with the most. So special note to make here. So irrational numbers, like I mentioned already, you'll be able to identify them by looking at its decimal equivalent, and you'll actually see that they'll have non-repeating decimal digits, right? And I probably should have said decimal digits. I apologize. I think that's what I meant to right there. That makes more sense, but that's okay. So as an example, pi is 3.14159265359, blah, blah, blah. But if you put this in your calculator, you can test it out yourself. There doesn't seem to be a lot of repetition in the digits, right? So because the digits don't actually repeat themselves, that kind of gives us a hint that this is not going to be a number I can switch into a fraction, right? Perfectly, right? Because technically there's an approximation of pi. It's 22/7. And you maybe heard about that in elementary school, right? That I can write this as a fraction, but that's not actually true. It's just an approximation. This isn't actually the most accurate measure. Square root of 2, you can put this in your calculator. Square root of 2 is 1.41421356. etc., etc. But what you notice is that there are no repeating, there doesn't seem to be a pattern that repeats over and over in the decimal equivalent. So because of this, it is also very likely that it's a rational number. So these are two examples of irrational numbers, and you can see here that there's no repetition there in the digits. There doesn't seem to be a pattern. The rational numbers are, just so everyone's clear, the other kind of important point to make is they can actually be positive numbers, negative numbers, or zeros. And all integers, and this is where people sometimes get a little thrown off. Integers are positive and negative whole numbers, including zero. And sometimes people are like, well, can I write that as a fraction? Because that's the definition of a rational number, is that you can write it as a fraction. But you can always write any whole number as any whole positive or negative whole number, so integers, as fractions. You simply put a 1 underneath it and it becomes a fraction. So as an example, -6, I can simply write it as -6/1. Note that I just put the negative in front of the whole entire fraction, right? So I can either put the negative in front of the whole entire fraction, or I could put the negative in just in the numerator in front of 6. We'll talk a little bit more about this and what different expressions that you could have for negative fractions. So if you want to compare rational numbers, the best thing to do is actually to change it to one common form. So you either switch them all to a decimal or you switch it to a fraction. So let's do an example here. So which fraction is bigger, -4.5 or -17/4? Now, just making a small note just to make sure everyone is understanding this. The fact that I put a negative in front of the whole entire fraction, what that means is the whole fraction is negative, right? And I'm emphasizing that. But just so it's clear, I also could put the negative in front of the 17, and I could put -17 divided by 4, like that. It's -17/4. That actually means the exact same thing. It doesn't actually change the value. It just looks slightly different. But overall, the main thing we have to understand here is that this fraction is obviously negative. So what we're going to do next is we are simply going to switch both numbers into a decimal or switch both numbers into a fraction. I feel like the best thing to do is to switch them both into decimals. I feel like most of us are a little more familiar with decimals. Might be easier for us. So I would switch them both to decimals. It might be a little bit simpler to do. So my first thing is to switch the -17/4 into a decimal. So to switch it into a decimal, what we're going to do is we are simply going to take apart our fraction here. So -17/4, if I kind of break it down, I can actually rewrite this as the product of -17 times 1/4, right? And you can check yourself. -17 times 1/4, I multiply -17 and 1, I get -17. I multiply, technically there's a 1 underneath, 1 times 4, and I end up getting 4. So I'm basically breaking down my fraction into the product of two different numbers. So -17 times 1/4, I can actually then rewrite the 1/4 as 0.25. And then I realized, okay, now it's pretty easy. All I have to do is multiply 0.25 by -17, and that ends up giving me -4.5. So which one is bigger? Now we can compare them more directly. It's a little more clear as to how they compare. So I have -4.25 compared to -4.5. And in this case, it's actually hopefully clear that -4.5 will be larger, even though it might seem smaller, right? If you're thinking about positive numbers, but because we're looking at negative numbers, it makes a big difference. -4.5 is actually going to be larger than -4.5. And the reason for that, again, if you kind of picture on a number line here, here is -4.5 is right here, and -4.25 is right here. I can clearly see that -4.5 -4.25 is more on the right than -4.5. So because it is more on the right on the number line, then obviously -4.5 is going to be larger. And of course, because -4.5 is equal to -17/4, then that means that -17/4 is greater. So just be really careful when you're comparing with negative numbers. Essentially, the rule of thumb here is you need to almost, if you want to visualize it on a number line, draw it on a number line, basically the further to the right it is, the bigger the number is. So speaking of negative fractions, and this is where people get a little bit confused, and I totally get the confusion. I know where this is coming from. So if you have a negative fraction, obviously in this case I have -1. Oops, sorry, just putting the marker back on here. I have -4/3. Right. And what we're essentially saying is that this whole entire fraction is negative. I can actually have two options here. I can either put the negative sign at the front in the numerator. I can put the negative sign in the denominator. But the main thing to remember here is that you cannot, because this is where people think, well, then I can put the negative sign wherever. Well, not just wherever, right? I cannot have a -4 over -3. This is not the same. Okay, so just so everyone is clear, that is not the same. And the reason for that is because you're taking a negative, dividing by another negative, which actually gives you a positive. So when we have a negative fraction, you can either place it in front of the whole fraction, in the numerator, or the denominator, right? But not in both. So hopefully everyone's kind of clear on that. And just so everyone also is aware of this, this tends to be the most common practice if a fraction is negative to put the negative sign in front. But a lot of times it's helpful to put the negative sign in the numerator, because we end up doing, especially when we're adding and subtracting fractions, because we're working with the numerators. Once we have a common denominator, it's really helpful to leave the negative sign in the numerator, because that's where we're going to work more with the numerator versus the denominator, right? Once we have a common denominator there. So just so everyone is clear, we normally tend not to write it like this. It's not that it's incorrect, but this tends to be kind of a weird way to write negative fractions, to put the negative sign in the denominator. And again, it doesn't really help either, because when you're finding a common denominator, you normally just want to consider the positive numbers. You want to find the common multiple for the positive numbers anyways, right? So we tend not to put the negative sign in the denominator. We tend to put it in the numerator or in front of the whole fraction. Another point to make about negative fractions is being really careful when you're switching from mixed numbers to improper fractions. So I think this example kind of says it best. If you kind of go back to the rule you learned in elementary school, you would normally think, so I'm actually going to do this question over here so you can see it on the side. I know it's written here, but I figured I should just do it with you, just so you can compare it. In elementary school, you learned the rule here, right? You take the denominator, you multiply by the whole number here, and then you add the numerator. So if I follow that rule, and if I follow it really blindly, like just, step by step, it's actually not going to work out well. So I end up getting 5 times -1, and then I add 1, right? So I take 5 times -1, and then I add 1, and then I simply divide by 5. You can do the math here. This ends up giving you -5 plus 1 all over 5. And I can see here that this ends up giving me -4/5. Now you can check yourself. -4/5, and if you put this on a calculator and then you compare it with -1 and 1/5, they are not the same. Even if I were to write this as a decimal, right? It doesn't make any sense. This as a decimal, in case you're curious, would end up being -1.2, right? Because 1/5, and just doing a little bit of math here, 1/5 is equal to 0.2. So what we're saying is this is -1 and 1/5. So I'm going to take -1. If I picture on a number line here, here's -1, and I'm essentially saying I'm going to take away 1/5 here. So I actually end up at -1 and 1/5. If I move it to the number line if I move it to the left on the number line. That's not the same as -4/5, because if you take -4/5, that actually means you're moving the opposite direction. You're actually moving to the right, and that would actually end up giving me -4/5, which is not the same answer here. So be really careful with this and so the rule here to remember is that you can still use this. You can still use that little algorithm you learned in elementary school to multiply the denominator by the whole number and then add the numerator. That's totally fine. But the rule is essentially to ignore the negative until you are done. So then if I follow that rule, like I said, I'll still get the correct answer, but I essentially just have to ignore the negative. So I'll just kind of redo this, and I'll erase this so you can kind of see step by step how I'm going to do it. Sorry, just erasing this here. So I have oops, let me put that marker back on, -1 and 1/5. I'm simply going to ignore the negative sign, and then I'm going to follow the exact same steps. So if I ignore the negative sign, I actually end up getting 5 times 1. So 5 times 1, and then I add the 1, and then I divide by 5. And then what I need to just remember is that I simply need to put a negative sign in front of the whole entire fraction. I'm essentially saying my whole answer will be negative when I'm done. So 5 times 1 is 6, plus 1 is 5 times 1 is 5, plus 1 is 6. I'm thinking of the answer. Divided by 5 is just all over 5. It's just right, all over 5. And then, of course, because it's negative, I put a negative sign in front. So this is the equivalent fraction there. So it's probably best, like I said, two different ways that you can do this. You can either use that little algorithm you learned in elementary school, or you can break down your fraction, right? So I hope this also makes sense as well. So essentially what we do is we take our -1 and 1/5 and we break it down into -1 minus 1/5. And so we're essentially just saying that we're taking away 1/5 from 1, right? And then if you actually break this down, if you do a little bit of math here, -1 minus 1/5, I can actually switch -1 into -5 over 5. And then I'm simply just taking -5 over 5 and I'm subtracting 1/5. So doing a little bit of math, -5 minus 1 gives me -6. And I can write that as -6 over 5. So just I hope you become comfortable with switching the negative sign from being in front to being in the numerator, right? And I hope it doesn't throw you off too much. This is where people sometimes get a little bit stuck. We'll see lots of examples of negative fractions, so you'll have a bit more practice, but just kind of wanted to introduce you to the whole idea of negative fractions and where the number is placed, right? Because this is where it gets a little bit tricky. So what we're going to do now is we're going to learn about the cross cancellation method. Essentially what this is it's a way to simplify our calculations when this is more so important when we are multiplying and dividing fractions, right? What this is going to do is it's going to simplify our work so we don't have to multiply with really, really large numbers. Hopefully not too large of numbers. So it's a way to simplify when you're multiplying and dividing. And again, the idea here is that you are simply dividing the numerator and the denominator by a common factor. And what this does is it will reduce our work so that we don't have to multiply and divide with really large numbers. And hopefully it just becomes a bit easier, right? That's the goal there. And I mentioned the common factor, but I should be a little more clear. Specifically, you probably want it to be the greatest common factor, right? You can technically always divide by a common factor and that will still reduce the work, but ideally you want to divide by the greatest common factor because this will simplify your work even more. So we'll look at a couple examples to see how this works. So let's say that your multiplication question asks you to multiply 5 quarters times 16 thirds. So what I would do in this case is obviously going back to the basics. I know that I can simply, and there's nothing wrong with this. I just want to be clear on this. This is a completely acceptable solution. You could just take 5 times 16, right? Multiply the numerators and then multiply the denominators, 4 times 3. That ends up giving you 80. 80 divided by 12. And then I have to start reducing my fraction. Now, in this question, you're probably wondering, well, why would I want an easier method? This is already pretty easy. But the reason I'm showing you this example is just how it works, but you are going to see some examples where it is very helpful to do cross cancellation, right? So if I'm looking at this fraction, I still have to simplify it. So in order to simplify this, I would try my best to find a common factor or a number I can divide both of them by. Just looking at this really briefly, I think I can divide both of them by 4. So this ends up giving you 20 over 3. And of course, 20 over 3, if I want to write that as a mixed number, I can actually write that as 6 and 2/3, right? So this is a way that I can simplify my fraction so it becomes a little bit easier to work with, right? So how does cross cancellation work? So cross cancellation, what you are essentially doing is you are trying to break down your fraction as much as possible. Sorry, you're trying to break down your numerator and denominator, so you're dividing by a common factor here. So in our case, we are simply going to take 16 and 4, and we're going to divide each of them by the common factor, which is 4, because I can see here that 16 and 4, even though they're across from each other, but they actually have a common factor of 4. So that means I can divide both of them by 4 in this case. So then I end up getting, if I divide both of them by 4, if I divide 16 by 4, I actually end up getting 4. And if I divide 4 by 4, I end up getting 1. So that means that I actually can rewrite this fraction, which was 5 over 4 times 16 over 3, as simply 5 over 1 times 4 over 3. And that's a lot easier to work with. And then 5 over 1 times 4 over 3 ends up giving me 5 times 4 divided by 1 times 3. And that reduces to 20 over 3, which of course I can write as 6 2/3. And you totally have an option here. You can write it as 20 over 3 or 6 2/3, right? You can write it as a mixed number when you're done. It's totally fine. Either answer is acceptable. So the idea here with cross cancellation is you can either cancel across, so you can actually find a common factor between the numerator on the left, on the right, and the denominator on the right, or the numerator on the left and the denominator on the right, or you can actually cross cancel within the fraction, right? So I could have also, let's say I had 16 over 4 like this times 1 over 9. I could also cross cancel within this fraction, but obviously this becomes pretty easy to do, right? That just becomes 4. So I'll give a different example. It's not as obvious how to simplify it. And I keep giving bad examples. Let me see here. Here's another one I can give. Sorry, 1 second. Let me just erase this. Okay, sorry. Just erasing this here. And it doesn't seem to work. Okay, these tech issues. All right. So as an example, I could have something like 12 over 8 times 1 over 9. And I can see here in this example that I could actually cross cancel within this fraction, right? So I could divide the numerator and denominator by 4, which ends up giving me 2 here, and this ends up giving me 3. So I could cross cancel like that as well. So there are different ways that I could cross cancel, right? So either across to the fraction, like I said, the numerator of one fraction and the denominator of the other fraction, or I can cross cancel within one fraction. But just so you're clear, we never ever cross cancel within the, comparing the numerators and comparing the denominators. You're not allowed to do that, okay? So just be careful with that. Like I said, this is a different method that we can use to kind of simplify our work. So our next step here is to, just going to the next part here. Our next step is to look at how to divide fractions. So to divide fractions, luckily, it's actually extremely similar idea. What you're gonna do is just like before, we're gonna multiply. In order to divide fractions, we simply find the reciprocal of the second fraction, which means you flip the fraction, right? And then we're just gonna multiply from there. And then keep in mind that if there are negative fractions, and I purposely gave you this example here, what I would do first, before even, this is where people get a little bit confused. They don't know where to put that negative sign. And this negative sign starts really playing mind games with them. So what I would do first is I would actually, whenever you have a negative number, a negative fraction involved, I would first figure out what the sign of the fraction, what the sign of the product or the quotient will be. Do that first before anything else. And again, this is more for division and multiplication, right? Because for division and multiplication, we have an easy little rule to figure out what the sign of the product or quotient will be. So before anything else, figure out what the sign of the whole answer will be. Well, I can tell you right now, because I'm dividing a negative fraction by another negative fraction, I know that my answer will be positive. So technically, because I know my answer will be positive, I can honestly just ignore the negative sign. Pretend it's not even there, because you know in the end, it's going to be positive. So what I'm going to do in this one is I'm going to think to myself, all right, well, first thing, I'll start with something easy. I'm going to flip around that fraction. So I'm going to flip around the second fraction. So that becomes negative 9 over 16. And keep in mind that I put a negative in front, but I know I kept the negative in front of both fractions, but I know in the end, when I multiply them, I'm going to get a positive answer anyways. So what I noticed next is that, and I'm sorry, I went a little too early there. What I noticed next is that the 3 and the 9 can both be divided by 3. So if I divide them both by 3, this reduces to 1, and this reduces to 3, right? 9 divided by 3 is 3. 3 divided by 3 is 1. And then I look across to 40 and 16. Now, it's not maybe as obvious that they have a common factor. I feel like 9 and 3 was a bit easier to see. But 40 and 16, you think about familiar numbers, and you're probably thinking, well, I can divide them both by 4, but I can also divide them both by 8, right? If you're thinking of the greatest common factor. So the greatest common factor would actually be 8, not 4. You could divide them both by 4, and just so you know, that still simplifies the work, but it's best to divide by the greatest common factor. And I can see here that my common factor would be 8. So I divide them both by 8. So 40 divided by 8 is 5, and 16 divided by 8 is 2. So that means that my fraction that I had before actually reduces to 5 over 1. I'm just looking at the leftover numbers, 5 over 1 times 3 over 2. And that becomes a lot easier to work with. All I'm doing is simply multiplying this fraction. And I know when I multiply fractions, I simply multiply across. So 5 times 3 is 15, and 1 times 2 is 2. And that is all I need to do in this case. So I can clearly see here that my quotient is 15 over 2, or I can actually write that as a decimal if I prefer, as 7.5. So next examples, we have a couple more here, and I just want to just kind of practice more and more with getting familiar with the cross-canceling method. Like I said, you don't have to use a cross-canceling method, but I really recommend that you start familiarizing yourself with it, because you are going to need this a lot more when you get to grade 11 and grade 12 math, especially in the IB program. We do this a lot. So you want to make sure that you really feel comfortable with this method. But like I said, grade 9 is kind of like your practice grounds, right? We're just kind of getting familiar with this. So let's try these examples. I hope you can try them. I hope you try them out yourself first. But let's do them together here in this case in the video. And I'm going to, for the first two, I'm going to use the cross-canceling method. For the last two, I'm going to show you how to just multiply it like normal. But I will also briefly mention the cross-canceling method you could use as well. So in the first example there, 20 over 5 times 12 over negative 12 over 4. So what I'm going to do is I'm simply going to multiply the numerator and the denominator. But before I get to that, I note what the sign is. So because what the signs are, the fractions are. So because the first fraction is positive, but the second fraction is negative, I know that my product will be negative, right? And so I look at this and say, all right, well, I know the answer will be negative. So because it's going to be negative, there's no point in even dragging around this negative sign. Let's just put it in front of the whole fraction. And that's exactly what I did here. I just put it in front of the whole fraction. So what I did here in this next step, and I kind of explained this, but just reiterate it again, we try to find any common factors here. So I actually noticed that the 20 and the 4 can each be divided by 4. So if I take 4 divided by 4, I end up getting 1. And if I take 20 divided by 4, I end up getting 5. That's how I ended up getting these numbers underneath. There is actually a different way to do this question. And to be honest with you, not a great question now that I'm looking back at it, because there's almost multiple interpretations of it. And a lot of people actually say, you know what, couldn't you have cross-canceled right here within this first fraction? And yes, you absolutely could. And actually, that would probably make more sense, right? So you could take 20 and simply divide by, sorry, I'm just going to change the color here. You could simply take 20 and divide by 5, and 20 divided by 5 actually gives you 4. So that reduces to 4 times negative 12 over 4. And then you can simply do the math from there. So there are different ways that I could use cross cancellation, right? And in this case, what I just simply did is I took 20 and 5 and divided each of them by 5, which is a common factor here, right? So that ends up giving me 1. Sorry, I meant to write divided by 5, and then this ends up giving me 4. That's how I ended up getting 4 over 1. So what I noticed here is that this fraction actually reduces to negative 5 over 5 times 12 over 1. And that becomes really easy to solve. All I have to do here is multiply the numerators and denominators, and keep in mind that I kept the negative sign in front the whole way through, right? I simply just kept it in front, just a reminder that the whole fraction is negative. And of course, when I multiply the two of them, negative 12, it's negative 5 times 12, that's 60, and 5 times 1 is 5. And then I get negative 60 over 5, which obviously actually can be reduced fully to negative 12. In our next example, so going back to the second example I gave you there, we notice that we have a negative sign in the denominator, and then we have a negative sign in the numerator. So obviously this fraction, the whole fraction is negative, and the whole fraction here is negative. So the rule here is that if I have a negative times a negative, then I know, sorry, a negative, yeah, multiplied by a negative number, then I know my product will be positive. So my answer in the end, even though it looks very complicated with the negative signs, the answer in the end is just going to be positive. So because it's positive, there's no point in me actually writing down all the signs. I'm simply going to put a positive sign in front, just a reminder that the whole entire answer is negative, is positive, right? So what I do next here is I simply cross cancel. So I know I wrote over here, but I feel like I'm just going to write on the side just so it's more clear, because I know sometimes it's a little hard to read there. So I'm going to think to myself, all right, what can I cross cancel here? Well, I kind of noticed a couple patterns. I noticed that the 5 and the 15 seem to have a common factor, and actually their common factor is 5. So I can divide each of them by 5. And when I divide by 5, this actually ends up becoming 1. And when I divide this by 5, this ends up becoming 3. And I'm going to do a similar idea for the other two numbers, 5 and 8. With 5 and 12. So with 5 and 12, I also, maybe it's not as obvious how what their common factor is, but I think to myself, all right, well, what number can go into both of them? Well, both of them can be divided by 4. So if I divide both of them by 4, I end up getting 2. And I do the same thing here. If I divide it by 4, I end up getting 3. So then this fraction that looked pretty complicated, to be honest with you, it wasn't going to be that easy to multiply this out. It actually reduces to something really nice and easy. It reduces to 1 over 3 times 2 over 3. And that becomes much easier to work with, right? 1 over 3 times 2 over 3. I know exactly how to do that. That's quite easy. I multiply across. 1 times 2 is 2. 3 times 3 is 9, and that becomes 2 over 9. So this is one of those examples where cross-canceling really simplifies the work. If I had not done cross-cancellation, I want to show you underneath just so you can compare. I would have had to multiply the numerators together, which would give me 40. And then I would multiply the denominators together, which would give me 12 times 15, which is 180. And then I would have to simplify this fraction, right? So then I have to think to myself, all right, what can I divide both of them by? So you probably want to divide by 10 just because they both end with 0. Then you end up getting 4 over 18, and then you want to reduce again. And that would, then you divide by 2, and that ends up giving you 2 over 9. So it's definitely possible to do it without cross-canceling, but it does take, in my opinion, takes a little bit longer, right? There's a bit more work to it. And especially when the numbers get really, really large and a bit more confusing to work with, cross-canceling will definitely help you out, right? Any little bit of cross-cancellation will just simplify the work. So we're going to correct the last two examples there. So let's say, so going back to the examples here so we can kind of compare. In our next example, we have a positive fraction multiplied by a negative fraction. So obviously, because we have a positive fraction divided by a negative fraction, we know our answer altogether will be negative. And for the last two, like I said, I just want to switch it up a little bit. I'm not going to use cross cancellation right away. I'm actually going to use our normal method, which is essentially just multiplying the numerators and multiplying the denominators and then simplifying it. We're going to use our normal method, and we'll kind of compare them, okay? So in this example, as I mentioned already, you know that the product will be negative because we're multiplying a positive by a negative. So because it's negative, you definitely do not need to put a negative sign in front the whole way through. Simply put the negative sign in front of the whole entire answer, right at the very front. So you have 3 over 8 times 16 over 9. So your next step here is to try to simplify, is to try to cross cancel so you can reduce this fraction. So if we have 3 over 8 times 16 over 9, I want to think to myself, okay, well, how can I reduce this? Well, I note that 16 and 8 both have a common factor of 8. So I can divide each of them by 8, and that makes 16 equal to 2. And sorry, that makes a 16 become a 2 when I divide by 8, and this makes it become a 1. And I do the exact same thing here. I divide the 9 by 3 because it can be divided by 3, and obviously 3 can be divided by 3 as well. So I'm simply dividing these two, the numerator on the left and the denominator on the right by a common factor of 3. So when you reduce this, this becomes 1. And then this, when I divide 9 by 3, this becomes 3. So then this reduces to 1 over 1. So I'm just going to show you two different ways. 1 over 1 times 2 over 3. And obviously 1 over 1 times 2 over 3 becomes 2 over 3, right? I simply just multiply across. So what if I didn't use the cross cancellation method? So if I didn't use the cross cancellation method, I would simply multiply 3 times 16, which is going to be 48. And then I multiply 8 times 9, which is 72. And when I multiply 3 times 16, I get 48. 8 times 9 is 72. I simply get negative 48 over 72. And then I want to simplify this. And I simplify by dividing by a common factor. And you want to divide by the greatest common factor to simplify further. So if you're having a hard time finding the greatest common factor, I would just start by dividing by any common factor, right? So you could technically divide by 2 and then continue reducing it. So let's just start from the beginning. Let's say you were a little bit lost on this. That becomes 24 over 36. Then you probably look at this, and I'm hoping you might recognize that this is, they're both multiples of 8. So divide them both by 8, and you end up getting 3 over, not 8. Sorry, I made a mistake here. Oops. Sorry, I'm not sure why I wrote 8 there. Typo. Sorry, guys, I haven't had my coffee yet. So you might notice here that they can both be divided by 4 to begin with, right? So we can start by dividing by 4. So if I divide them both by 4, then this reduces to 6 over 9. And then we might notice one last time here that I can actually divide each of them by 3, right? So if you divide them each by 3, you end up getting 2 over 3. So you notice that it took a little bit longer to get to the answer, but if you are pretty quick, you probably wouldn't notice, actually, hopefully you notice this from just looking at the hours in the day, that each of these are actually multiples of 24, right? So you can divide them both by 24. And if you had divided both by 24, you would have gotten the answer directly, right? Which is negative 2 over 3. Okay, so the last example here, so in this last step, just so you know, we still have to divide by, you still have to simplify your fraction all the time, right? So if I had left it as 48 over 72, that's actually not correct. I want to make sure I reduce it to lowest terms. So last example, it's a division question, just to switch it up a little bit. So because we have a negative number divided by a negative number, then we know the quotient will be positive, right? It's actually the same rules for division as well, which makes it easy. So what I would do first with this question, it's a little bit more complex than the other ones for a couple of reasons. I would first switch this fraction into a mixed number. I would switch this mixed number into an improper fraction. That's what I meant to say. So what I'm going to do first is I'm going to switch the first fraction there, negative 2 and 5/6, into 17 over 6. And I'm going to switch the second fraction, negative 1 and 1/12, into 13 over 2. And what I have next here is I simply have two different fractions that I'm dividing here. And it should be hopefully pretty easy. Now, like I said, in this case, I'm just going to do the normal method that we used before, and then I'm going to show you how to use cross cancellation if you decide to do that. So I know my answer will be positive in the end, so that's why I put the positive sign in front. It's just to clarify that the answer will be positive, right? If the answer is positive, you really don't need to put a positive sign, but I do it for these examples just so you're very clear that the answer 100% is positive, right? So I didn't forget, I didn't just ignore the negative sign, and sometimes people think I ignore it. I didn't ignore it. I did it on purpose because I know that a negative divided by negative will give me a positive anyways, right? So instead of me dragging around that negative number throughout all the steps, I simply put a positive sign in front. It's a little reminder to myself that the answer is going to be positive anyways in the end. So now that you know it's positive, then you can just do simple division here. So we have 17 over 6 divided by 13 over 12. I know I can simply flip the second fraction, and that becomes 17 over 6 times 12 over 13. And I am going to, like I said, in this case, I'm just going to multiply the fraction like I normally would. I would take 17 times 12 and then divide that by 16 times 13. 17 times 12 gives me 204. 6 times 13 gives me 78. Now, once I get to this step, again, if you are not using the cross cancellation method, then technically you would have to try to reduce this on your own. Now, it may not be that clear what the common factor is. To be honest with you, it's not one of those easy examples. I personally don't think it is, where you know exactly how to reduce it. But I would just start with something simple. You know they're both even, so divide by 4. So I'm just showing you kind of different ways you could do this, right? If you're really lost on this, where would you start? So I would start with something simple. They both they're even numbers, so divide them both by 2. And I think I said 4 by accident, so I meant 2. You're going to divide them both by 2 here, and you end up getting 102, and 78 divided by 2 is 39. And then what I do next is I simply look at this and say, all right, well, can I go any further? I'm not sure if anyone has learned this trick from elementary school. Hopefully you might have learned it. If you want to check if a number is divisible by 3, you can actually add the digits of the number. And if the digits of the number, if the sum of the digits of the numbers can be divided by 3, then the whole number can be divided by 3. So we can actually use that trick to help us. So 1 plus 0 plus 2 gives us 3, and obviously 3 can be divided by 3. So this means I can divide this by 3, and you can even check it on your calculator. And 39, I can definitely divide by 3. I know this because I know that 3 times 12 is 36. So 3 more is 39. So I can divide it by 3. So if I divide 102 by 3, that ends up giving me 34. And 39 divided by 3 ends up giving me 13. So there's one way I can do it, right? And there's nothing wrong with that. It's just that you can see here, it took a little bit longer to reduce it. Now, again, I know some of you might be really good at mental math. If you're really good at mental math, you might have maybe figured out that they can both be divided by 6. Now, a different way to do this, and this is personally what I prefer, and again, once you kind of got the hang of it, is use cross cancellation, right? So what I do here is I look at my fraction and I ask myself, all right, is there anything I can cross cancel? Well, I noticed that 6 and 12 can actually both be divided by 6. So if I divide 6 by 6, I end up getting 1. And if I divide this by 6, I end up getting 2. So this becomes a 2, and this becomes a 1. 17 and 13, looking across here, there's nothing I can really cross cancel there, so I'm going to leave them as they are, right? And just so you know, you can't like double dip, right? Like I can't like use the 12 to cross cancel with the 6 and then use the 12 to cross cancel with the other denominator, right? It doesn't work that way, right? Just so you're clear on that. So I end up getting 17 over 1 multiplied by 2 over 13. And then this becomes pretty easy to work with. 17 over 1 times 2 over 13, that becomes 17 times 2. And I apologize for going across, but it's just I'm running out of space here. And then 1 times 13. And of course, that reduces to 34 over 13, which is actually the exact same answer I got over here. So it's up to you what you prefer. In my personal opinion, I find a cross cancellation a little bit easier. It simplifies a bit of the work. And then, of course, as you can see here in this last step, I can definitely switch the improper fraction into a mixed number. I can switch it back to a mixed number, and that will be written as 2 and 8/13. So we're almost done here. We have just 2 more slides to kind of get through. So what happens when we add and subtract rational numbers, right? So luckily, when we're adding and subtracting rational numbers, it actually kind of works the exact same way. We essentially are following the same rules as before. We always follow BEDMAS and we follow the same strategies. The only difference is that when you're working with negative rational numbers, you really have to be careful about where the negative sign goes. This is where people really, really gets confused, right? So we'll talk a little bit about this, and I hope this example kind of helps illustrate this, right? It can be a little bit tricky working with negative fractions, but as long as you're careful about where the negative sign can be placed, then you're fine. So let's look at this example. So we're asked to simplify and obviously evaluate this expression. So we have negative 2 1/4 multiplied by, and in brackets, negative 3 3/4 minus 7 5/6. So the first thing I'm going to do is I am obviously going to follow BEDMAS, which means I need to do the brackets first. So because I do the brackets first, I will obviously consider this expression here first. So I'm going to find out what -3 3/4 minus 7 5/6 is. Now, before I even get to that, I would recommend switching the mixed numbers into improper fractions. And the reason for this is just like before, like we talked about, it's much easier to work, especially when you're subtracting fractions, it's normally easier to work with mixed numbers. So what I'm gonna do, sorry, improper fractions, so I keep making mistakes here. So it's easier to work with improper fractions. So what I'm gonna do is I'm gonna switch the mixed numbers into improper fractions. And again, when you're doing this, I just wanna remind everyone, be really careful, as I mentioned already, when you're switching negative mixed numbers into improper fractions. You want to make sure that that you're not using the little shortcut incorrectly, right? So if I take 4 times -2 and then I add 1, that's not going to give me the correct answer. I essentially need to do this. I ignore the, like I said, ignore the negative sign. So I'm going to take 1 times 4, and I'm simply going to multiply, 4 times 1, and then I'm simply going to add the numerator, which is 1. So 4 times 2 is going to give me 8, and then I add the numerator at the top, which ends up giving me 9. And then, of course, because it's 9/4, I simply just put a negative sign in front, and I write it as -9/4. Okay, so that's how I switch the mixed number into an improper fraction. And I'm going to do the exact same thing here. So if I want to switch -3 3 3/4 into an improper fraction, I'm simply going to take 3 times 4, which is 12, and I'm going to add the number at the top. And again, I'm just ignoring the negative sign for now, right? So that ends up giving me so 3 times 4 plus 3, that ends up giving me 15/4. And 15/4, and then of course I put a negative sign in front, okay? So when I'm doing this, and I simply just switch to an improper fraction there. So I have my improper fraction, so I end up getting -15/4 minus 47/6, and I just made a mistake here. And I'm just realizing that right now. That's why, if you notice, I was kind of thinking about this question a little bit more carefully, is because I just realized that I think I made a mistake here last night when I was doing the solution here. So it should be -15/4, which will obviously switch around our answer a little bit. So just be clear that I made a mistake here. So I'm going to have to switch that later on. So if you don't mind checking this PowerPoint right after, I am actually going to update it right after I post this video. But for now, you can just still go through the steps. We'll do this together. So essentially what I did is I switched this mixed number into an improper fraction becomes -15/4. And just keep in mind, it's not -11/4, right? And then of course, 7 times 6 is 42 plus 5 is 47. So doing a math here. So 6 times 7 plus 5, I'm actually going to check all my answers, make sure I didn't make any mistakes here. And then I put a negative sign in front. So that actually ends up giving me -47/6. Perfect. Okay, so I have -47/6 as the second fraction there. So what I'm going to do now is I'm simply going to subtract these two fractions, but in order to subtract, I need a common denominator. So my common denominator in this case is 12. So that means I have to switch both fractions so that they have a common denominator, 12 here. So -15/4, when I rewrite that as a fraction with a common denominator 12, I know I'm going to have to multiply 4 by 3. So I have to multiply 4 by 3. And if I multiply the numerator by the same amount, if I multiply by 3, it won't actually give me 33. It will give me 45. So I made a typo there. So I'm just going to kind of show the steps here. So what I'm really doing is I'm taking -15/4, and I'm thinking to myself, all right, if I want to switch it to have a denominator 12, I simply multiply by 3, which means I multiply the numerator by 3 as well. And that ends up giving me -45. Now, this is where people get a little bit confused because they're kind of looking at the negative sign here and they're thinking, I don't know what to do with the negative sign. just keep it either in front of the whole fraction or in the numerator. I personally prefer to put it in the numerator, especially if I'm doing more calculations with the fraction. I like to put the negative sign in the numerator. It just makes it easier for myself. So put the negative sign in the numerator in this case, right? Because I'm just multiplying here. So I have negative 45 over 12. So now in our next step, I had to switch the second fraction. So to switch the second fraction into a denominator 12, I multiply this by 12. Sorry, I multiply by 2. That's what I meant to say. I multiply by 2. So 6 times 2 is 12, and 47 times 2 is 94. So that's, and again, it's negative because there's a negative sign in front. So just showing the math here, I'll just show the steps so everyone is clear on how I got this. I am simply changing the 6 into a 12. And again, I would put the negative sign in the numerator. It makes it easier. So you know I have to multiply by 2. So you multiply this by 2, and this ends up giving me negative 94. Okay, so now I have negative 45 over 12 minus negative 94 over 12. Now that I have a common denominator, I can simply subtract these two fractions here. So I'm going to subtract off, and I end up getting, and I mentioned this already, put the negative sign in the numerator. So I'm going to take negative 45. Sorry, guys, I'm just making all these little changes. Minus 94, which means that I simply take negative 45 and I subtract 94. So negative 45 minus 94, doing a little bit of math here. So I wrote negative 127 over 12. That's obviously not correct. So I'm going to switch that as well. So negative 45 minus 94 gives me negative 139. So I'm just going to change that here. So negative 139 instead of negative 127, okay? Now, what I'm gonna do next is I'm simply going to multiply across, or I could use cross cancellation. In this case, I am actually just gonna multiply across for now, okay? So when I multiply across, I end up getting 9 times, and of course, just a quick little thing here, because I am now multiplying a negative number by this negative fraction that I got for the difference, we know that a negative times a negative will actually be a positive. So because it's a positive, I can put a positive sign in front as a reminder, but I know the whole answer will be positive anyways. So because it's positive, I just ignore the negative signs. I know the whole answer, the whole product in the end will be positive. So now I take 9 times 139, and I'm just going to erase that here, or just cross that out. So 9 times 139. So let's do a little bit of math here. That ends up giving us 9 times 129. Sorry, 139. I typed it in wrong. 1,251. And 4 times 12 is 48. So once I get to this step here, 1,251 over 48, I still want to be able to reduce this fraction. And again, all this is wrong. So I'm just going to delete that. So I'm going to erase that so it doesn't confuse you there. So what I'm going to do is I'm going to take my answer, which is 1,251 over 48, and I'm simply going to try my best to reduce it. So if I'm reducing this myself, and you're going to see this live here because I haven't actually done this question, because the numbers switched around a little bit, I am going to divide by a common factor that I can think of, right? So if you're having a hard time thinking of common factors, just start off with something easy. I can tell you one number that could work. So if I have a 48, obviously I know lots of different numbers that I can divide by. I could divide by 2, that won't work for the numerator. Most likely 3 will work, and I can just double check. So 1 plus 2 is 3, plus 5 is 8, plus 1 is 9. So because I can divide the whole entire, the sum of, it's because I can divide the sum of the digits by 3, then I know I can divide the whole number by 3. So I divide each of them by 3, and that ends up giving me 417. And this is going to be over 48 over 3, which is 16. So 417 over 16. This right here is what it reduces to. And I have to think to myself, all right, is there anything else that I can divide by? Well, 417, I wouldn't think of the factors of 417 because you're probably not that familiar with them. But 16, there's not that many factors, right? I could divide 16 by 1, but that doesn't do anything. I could divide it by 2, but that won't work here. I could divide it by 4, but that won't work because this is an odd number. I could divide this by, I could divide 16 by 16, and that's it, right? I believe that, and 8, of course, I missed 8. But none of these will work because these are even numbers here. So I can see that's not gonna, there's no way that that can be one of the factors of an odd number. So because we have an odd product, we can only have odd factors, and it's where none of these are going to work up here. Sorry, none of these factors here of 16 are going to work. So it seems that this is as far as we can go. So we leave it as is. So the answer will be 417 over 16. And of course, I can reduce that. I can switch that into a mixed number if I prefer. So as a mixed number, it would become 26 wholes. And you can actually check this yourself. It goes in 26 times. So 26 times 16 is 416. And I have 1 left over. So it's going to be 1 over 16. And I can leave my answer like that. Now, a different way to do this, and I'll just show you the other way, using cross cancellation. So I'm actually going to do this in a different color so you can compare. Now, if I had done cross cancellation, I personally think that this would have been a little bit easier. And again, everyone has a bit of a preference. So 9 over 4 times 139 over 12. So I'll show you how, in my opinion, it makes it a little bit easier to use cross cancellation. So I look at this and I say, all right, well, how can I reduce this? Well, I can divide the 9 and the 12 by 3. And if I divide by 3, this ends up giving me 4. So I divide by 3, this ends up giving me 3. 4 and 139, there's actually no common factor that I know of because, well, we know that 4 can be divided by 4 and it can be divided by 2, but none of those, and obviously 1, but 1 doesn't do much. And none of those numbers will go into 139, right? 2 and 4 doesn't go in. So it doesn't seem that I can reduce the 4 and the 139, right? So I just leave it as is. So then what I do is I go back to my question here and I say, all right, well, this is hopefully going to reduce a little bit to a nicer number here. I have 3 over 4 times 139 over 4. And when I multiply across, I have 3 times 139. And let's do the math. 3 times 139 gives us 417. And then 417 is then divided by 4 times 4, which is 16. And so this reduces to something a little bit nicer. Now, you can kind of see the difference there. I personally find this a bit easier because then you don't have to worry about potentially finding the factors of really large numbers because hopefully the numbers will become quite small that it'll be easier to work with in the end. So just careful. I know it's really bad notation. I don't want you to do that on your test. I obviously did this because I was running out of space there. And just to keep in mind, I've made a mistake with this one, so I will definitely make the changes right after the video. So our next part here, this will actually be pretty easy, but this is one of the word problems that comes up, and it's a little review of grade A, finding average. So if you're finding the average of numbers, then all we're really doing is we're simply adding all the numbers and dividing by the total number of values that you have. So if I ask you for the average temperature for 7 days, and I list off the temperatures here for you, all you're really doing is simply adding up these numbers and dividing by how many values we have. In this case, we have 1, 2, 3, 4, 5, 6, 7. Oops. Did I get more values? Yes, I did. Sorry, again, another mistake. Sorry, guys, I apologize. I did this a little bit late, so I definitely could have made a couple errors. I actually meant to say 7 days, and I actually ended up adding an extra number on there, which doesn't really make sense. So I'm actually glad I'm testing this out here. So let's, you know what? Let's just switch around the question when we're doing the math here. So I'm just going to ask you to just switch it to 8 days, okay? I know it says 7, but I'll switch it to 8 days. So what I'm going to ask you to do to find the average is simply add all these numbers up and then divide by 8. So I'm going to take -9 plus -15 plus -10 plus -2 plus 0 plus -5 plus 1 plus 4, and I'm going to divide by 8, which is the total number of values. So when I add them up, I get -9 minus 15. And again, the reason I subtract 15 is because I'm adding a negative. So when I add a negative, I actually just subtract. And again, same idea here. If I add a negative, I'm simply subtracting. If I add a negative, I simply subtract. So this is pretty easy, I hope. Then I add the 0. And then, of course, I'm subtracting. I'm adding a -5, which means subtracting 5. And I'm adding 1 and I'm adding 4. And so I'm simply going to add up all these values in the numerator and divide by 8. And that, I'm just going to double check the math here. -9 minus 15 minus 10. And you can definitely let me know if I make a mistake with this myself. I apologize. I've made a couple errors in this lesson. So if you spot anything else, let me know. I end up getting -36 over 8. -36 over 8 actually gives me -4.5 degrees Celsius. I'll leave it like that. Okay. So the average temperature ends up being -4.5 degrees Celsius. Just a small little note here. You can see here that in that last example, I actually ended up leaving like using this approximation symbol. That just means that the answer is approximately that, right? But in this case, my answer ended up being -4.5 degrees Celsius because I divided by 8 instead. So I'll make those changes on the note right after this lesson, but that is basically it. And of course, here are the assigned questions. And again, you're going to notice that there are some questions that say extra. If it says extra, it just means it's an extra. It's a bit more of a challenging question, so you don't have to do it, but it's optional. And I would definitely recommend if you're looking for a bit more of a challenge. And any questions that have a little star there, it simply just means that they're really good questions. Don't skip them because you may see them on assessments. Okay. So I think that's everything for now. So best of luck with the work today. Take care.